Okay, this is on section 8.2 on adding and subtracting rational expressions. Anytime you see the word rational in algebra, that usually means rational expression means there's a variable down in the denominator. So these are going to be adding or subtracting rational expressions with variables down in the denominator. Okay, the key on this, when you get to the final answer, is to remember to reduce all fractions. We've been doing that all year, so I really don't think that's going to be an issue, but make sure you reduce all your answers. One thing they go through in this section is how to find a common denominator, and they actually go through how to find the least common denominator. Before I take you through one with algebra, I want to take you through one with just arithmetic and show you how I do it, okay? And how the author would do it. And it makes a difference. They'll say add or subtract. On these, the directions is to add, and they give you the fraction 8/15 plus 4 over 250 minus, yeah, we would end up subtracting the 1/9 there. Okay, now just looking at that, by sight, do you know what the LCD is, the least common denominator? Least common denominator. Least common denominator? Okay. Okay, so now I'll take you through the process. What I do first is I factor the denominators. So, and I want you to do it in the problem. So right below this, factor the 15 into primes. You break each one of those denominators into prime numbers. And if you have to do some scratch work outside, like 250 is 25 times 10, and that'd be 5 times 5 times 5 times 2, right? So this would be 5 times 5 times 5 times 2 minus, and the 9 would be 3 times 3. So the first step is to break each one of those. I don't care about the numerator as far as breaking it down. It's the denominator. So you break each denominator down into prime factors. Then if it's just involving numbers, then you find the LCD. LCD stands for the least common denominator. Okay, and here's how I say it. To find the LCD, take each prime factor, the greatest number of times it appears in any denominator. Okay, so take each prime factor, the greatest number of times it appears in any one of those denominators. So out at the side, I would look at my denominators and I'd say, in the first fraction, the 3 appears once. In the second fraction, the 3 in the denominator doesn't appear. That's 0. Second fraction, it appears twice. Greatest number of times is twice. So you need it twice in your LCD. In the first fraction, 5 appears once. Second fraction, 5 appears 3 times. Third fraction, 5 doesn't appear. Greatest number of times, 3. In the first fraction, 2 does not appear. Second fraction, 2 appears once in the denominator. So, and the last one, it does not appear. So I need it once in my LCD. Okay? Now, even without, I'm not even going to multiply out that denominator. But that is the least common denominator. What that is the smallest number that 15, 250, and 9 will all divide into evenly. Okay? So, what I do next is you put everything over this denominator. So we're going to write out do the same thing for this one. Whoops. Sorry, I need to write it the same way. You may have to write kind of small. So we're going to put everything over that LCD. Now, I look, and if you have a highlighter or a different colored pen, I look at this denominator, and I find it down here, and say, what did I multiply that 15 by to get that other denominator? I had to multiply it by this 3, by this 5, and this 2, right? So 3 times 25 would be 75, 150. So I got to take 8 times 150. So really I'm taking 8 times 150. Okay, I look at this denominator, find it down here. What do I have to multiply that denominator by to get that bottom one? Find this down here. What do I have to multiply it by? 9. 9 times 4, 36. You can write 9 times 4 or 36 up there. Look at this denominator. What did I have to multiply that by? Down below. 5 times 5 times 5, 125 times 2. 250 times 1. Okay, so now on top, I would go ahead and simplify 8 times 150. If you multiply that out, you get 1,200. 9 times 4 would be 36. Minus 250. And it's all over the same denominator. Now, I don't even, I can leave it as 3 times 3 times 5 times 5 times 2. And I can say that, if I simplify that out, is 986 over. The reason I don't multiply it out is I want to look at that factored form. 986 is what type of number? Ends in a 6. Even. Can we reduce anything? Look what's on bottom. Yeah, reduce the 2. Right? 2 will go in here once. 2 will go in here. 493. So I get 493 over 1,125. Okay, now on your calculator, somebody on your calculator, take 9 times 125 times 2. Take 9, that denominator, take 9 times 125 times 2. Or you can take this denominator at the end times 2. What is it? Okay, so final answer. Okay, that is so much easier than trying to work it not in prime form when you get larger numbers. And really in 4th, 5th, 6th grade, it's tough because they don't know the vocabulary, but in 4th, 5th, 6th grade they also rig the problems where, you know, the numbers are smaller and you can kind of figure out. Now, you can always go back and find the greatest common denominator. Somebody take your calculator, take 15 times 250 times 9. What's that number? 33,750. Yeah. So this denominator, what did we say this was? 2,150, is that right? No, 2,250. And the greatest common denominator, what did you say, 33,750. If you worked it using the greatest common denominator, then you have to worry about reduce your answer. Okay? I would not do it with the greatest common denominator. You do it with the least. Okay? Okay. That was with just numbers. Okay, now Instead of LC, yes.
I'm sorry, but I'm having a terrible time understanding where you got 4 out of all those numbers.
Where I got what?
Oh, like on the middle one, you have 4. 4 times 4, or 9 times 4.
Oh,
You should have
yeah.
9 on the inside and the 4 on the outside.
Yeah.
Oh, just, okay, the 4 is from up here. And then I look at this and say, okay, find that down below. And what did I multiply by? Oh, sorry, from this to here is a 9. So 9 times 4.
Whatever is uncircled goes up.
Does that bother you that they're not in the right order? Does that bother you that they're not in the right order? Sorry. Okay. Okay, good with that? Does that help? Okay, sorry. Should have kept in the right, same order. Okay, now, the LCD stands for least common denominator. Now the author is going to go to least common multiple. Okay, the least common multiple means he's going to throw in the variables. Okay, so LCM stands for least common multiple. Okay, so if I say find the least, actually I'm going to move this down now. Find the, if the direction said find the least common multiple or the LCM, and they give you 3. Okay, so let's say they gave you 15, A to the second, B, C to the third, then a comma, 16, B to the fifth, C to the second. Another one is 20, A to the third, C to the sixth. So what the author's saying is, suppose those 3 were in the denominator. What's the least common multiple? Okay, so you want to break it into primes. Okay, each one of those numbers. So 15 is 3 times 5. And for right now, I'm just going to show you writing it out the long way, and then I'll show you the shortcut. A squared is A times A. B is just B. C cubed is C times C times C. 16, I could go 4 times 4 and then break that into primes. 2 times 2 times 2 times 2 would give you 16. B to the fifth is B, hang on, write it the long way. B times B times B times B times B. C to the second, C times C. That one's done. 20, 4 times 5, I can break the 4 up. 2 times 2 times 5. A times A times A. C to the 6th, right out. Just barely. Okay? To find the least common multiple, you take each prime factor the greatest number of times it appears in any one of those. How many times does the 3 appear?
Once.
Once. How many times does the 5 appear? Once.
Twice. Oh no.
Once. Greatest number of times in any one of them. And 2 appears. 2 appears 4 times. Okay, that's going to be the coefficient. Now look at the A's. How many times does the A appear?
3.
Which would be A to the third. How many times does the B appear?
5.
In any one, in the first one it appears. Oh, did I leave one out? No, I got there. There's B to the fifth, right? C.
6.
6. Okay, then you multiply. 3 times 5 is 15. 15 times 2 is 30. 30 times 2 is 60. 60 times 2, 120. 240. Okay, so the least common multiple is 240. A to the third, B to the fifth, C to the sixth. Least common multiple, 240. Now, instead of writing out, you can always write them out the long way. But if you just look at the exponents, if you look at the A's, which one was our answer? The highest exponent, right? It had to be, yep. B, which one was the answer? B to the fifth. The C's, which one was the answer? So make a note out at the side there. Which exponent did we choose? Make a note. On your own. Make a note. We choose the highest exponent. You do not have to write out the long. You don't have to write this out unless you want to. Unless you choose to. Just choose the highest exponent. Okay? Or you break them down into prime factored form. Okay? Yeah, you still. I would. Yeah. Okay. Let's do another one. Still find the least common multiple. Okay, the first one is x to the third minus x squared minus 2x. Leave a space. Second denominator would have been x squared minus 4x plus 4. Leave a space. We only have two of them. Okay. Okay, you cannot work these until you get them factored. So look at the first one. What is in common? X. Take out an X, one set of parentheses. What's left? Minus X minus 2. Break that down. Two sets of parentheses. Look at this sign first. 2 and 1. Signs?
Different. The larger is going to be negative.
Yes. So minus and plus. Do you agree with that? Okay, now you factor this one. Nothing in common. Two sets of parentheses. X and X. What about the signs? This tells you they're alike. This tells you they're both negative. 2 and 2. Okay, so now you look at both factored forms and choose the LCM. Okay, so look at both of them. How many times does the X appear by itself? Once. So you need it once. That's the greatest number of times. X minus 2 appears twice. So you need it twice. Greatest number of times. X plus 1 appears once. And this is the least common multiple. Okay? Everybody okay? Caitlin, which part?
Oh,
Are we good? Yep, okay. One more. Okay, so first one is 2k to the third minus 5k squared minus 12k. The second one is k to the third minus 8k squared plus 16k. Okay, on the first one, k in common, and we'd have what? 2k to the second minus 5k minus 12. Keep going. We need a 2k and a k, right? Now this is where we did that. Some of you did triple play, and I do 2 and 1, and all the factors of 12. I could do 1 and 12, 2 and 6, 3 and 4, and I need them to differ by 5. We didn't mess up on a sign. Oh yeah, it does. 2 times 4, 1 times 3, 8 minus 3. Okay, so I need 2 times 4, and I need this one to be the minus and this to be the plus. Okay. And you know, if you don't like my method, use your triple play method, but you got to get it factored completely. Okay, now factor this one. What's in common? And we'd have k squared minus 8k plus 16. This one's not so bad. That is a trinomial square. Yep. And what about the signs? Both negative. Okay, now you do the least common multiple. K appears once in the first one, once in the second one, greatest number of times is once. 2k plus 3 appears once. K minus 4 appears once. K minus 4 appears twice, greatest number of times, twice. And that is your least common multiple. Okay. What's that? Quantity squared? That's fine. I would guess probably you're greater once it this way, though. But it would be all right. Okay? Okay, now that you know how to find the least common multiple, now we're going to put it into adding and subtracting. Okay? Okay, they will say simplify, and you got to pay attention to the signs. It'll say simplify, add, or subtract. Okay, and the only thing you can do when you're adding or subtracting fractions is to get a common denominator. And people, yes, there's some steps to get a common denominator, but if you factor it, take each prime factor the greatest number of times, you're going to get the least common denominator. That's the easiest way to do it. Otherwise, you're guessing by golly. Okay, that doesn't work very well. Okay, so first fraction, 5a squared all over 6b. Because sometimes my b's look like 6's. So, plus 9 over 14a squared b squared. Okay? Now, the first thing I do, you can do that LCD or LCM out at the side, but I like it in the middle of the problem. For me, it makes it easier if I do this. Say 6 is 2 times 3 times b. And I still have the same thing up on top. 14 is 2 times 7. And we already know, I'm not going to write that out the long way, because I already know I'm going to pick the highest exponent. Okay? Now I'm going to do the LCM on the bottom. 2 appears once, and once, greatest number of times is once. 3 appears once, and 0, greatest number of times is once. 7 appears 0, and once, greatest number of times is once. A appears 0, and twice, greatest number of times is twice. B appears once, and twice, greatest number of times is twice. This is the LCM. Okay, now, here's where you look. And I would circle it or highlight it, even with a different color, and say, okay, this to here, and we just had one, right? One of those. Okay, what do I have to multiply from this denominator to get this?
7a squared.
7a squared, and also b, right? You got to be careful with that if you do highlight it. Okay, so I need to multiply the top times 7.
35.
So that'd be 30. Let's write it out the long way first. Let's write it out. 5a squared, and I'm multiplying it by 7, and you said a squared, and you said b, right? Okay, look at the other denominator. What did I multiply this denominator by to get this? 3.
Just a 3.
Just the 3. So I need, sorry, I left out the 9. I left out that 9, I think. So it'd be, I need to keep it in the same order. 9 times 3, right? Okay. Okay, now multiply them out. So this would be 5 times 7 would be 35. A squared times a squared. A to the 4th, b. And it's still on the bottom. Same thing. Okay. This would be 27, still the same denominator. I don't multiply out that denominator until the end because I want to be able to factor and reduce. I want to be able to reduce it. Okay, so I would have up on top 35, a to the fourth b plus 27. They have the same denominator, so I can put them together. It's just like saying if I add 1/4 plus 2/4, I get 3/4. If they have the same denominator, I can add the numerators. This denominator is going to stay. Okay, now, what is in common on top? Anything? On just the top, is there anything in common? No, can't factor that out, can I? Nope. Okay, then I need to go ahead and multiply it out. Okay, now multiply out. So I always check that to see if there's anything I can reduce. So the top stays the same. 2 times 3 would be 6. 6 times 7, 42. A to the second, b to the second. Now, some people, you guys, and you have a choice. Some people would write that 42, they write this as the 42 a to the second b, and this is the 42 a to the second b. But to me, it's easier to figure out what did you multiply by to get that denominator if it's in factored form. Okay? So this is your final answer.
You can't reduce it A or B.
No. If it was a time sign, you could. You can't do slash marks around the plus or minus sign. Okay? Okay, let's try another one. See, that one was number 5. Okay, number 6. So you have x plus 10 all over 3x minus 15 minus, in the numerator, 3x plus 15, and it's all over 6x minus 30. The first thing you should do is break down the denominators. Leave that top part the same. What's in common on the bottom? 3. 3 is in common, and what's left?
X
Minus 5. And it's a minus sign. Leave the numerator the same, 3x plus 15. What's in common on the bottom? 6 and x minus 5. Okay, and now you find the LCM. 3, oh, wait a minute. I can break that 6 down, can't I? I'm going to go one more step there. I'm going to change that to 3 times 2. Okay, so 3 appears once, and once, greatest number of times is once. 2 appears 0 times, and once, greatest number of times is once. X minus 5 appears once, greatest number of times is once. So actually that second one is your 3 times 2 or 2 times 3. That is your, I wrote those different, but they're the same thing, aren't they? 2 times 3 is the same as 3 times 2. So that second one is your LCD. What did I multiply? This denominator by to get this? 2. So take that top part times 2. The critical part is you got to have parentheses around the x plus 10. And on the top, the bottom's the same on this one, right? Same. Top stays the same. 3x plus 15. Okay. Multiply out. You got to multiply this out. Would be 2x plus 20. Okay. Now be very. Here's the part you got to be very careful. This minus sign applies to both things on top. So it's going to change this sign to make that a negative 3x. It's going to change this sign and make that a minus 15. So if you're subtracting a quantity, it changes both signs in the numerator. It does not change the denominator. Okay? And it's still over 3 times 2 times x minus 5. Now combine like terms. 2x minus 3x, negative 1x, right? Plus 5. And it's all over 6 times x minus 5. Are we done? What's the little trick to this? Don't they both look alike except for the signs? Negative x, positive 5, negative 5. Out of either one of them, factor out a negative 1. Okay? Doesn't matter which one. I took it out on top. So negative 1 would make that x minus 5. It just changes both signs on top. 6 times x minus 5. Now what's going to reduce? The x minus 5. You have to check to see if both quantities they look alike except for the signs. The little trick is you got to factor out a negative 1. I took this and factored out a negative 1. So that's going to change that sign. You still have to be able to multiply, like if I multiply this back, do I get negative 1x? If I multiply this back, do I get positive 5? Yeah. So final answer is negative 1 over 6. Okay, last example. This is an example of a complex fraction. Did you work with any complex fractions in Algebra 1? Or no? Okay. Okay, up in the numerator, you may want to look up here first. It's 1 divided by x minus 1 divided by x all over, and usually I try to make that a little bit bigger. Down in the denominator, it's 1 over 1 plus 1 over x. So you have fractions within a fraction. Okay? When you have a fraction within a fraction, you look at all 4 denominators. Look at all 4 of these and find your LCM with all 4. Okay, looking at all 4 denominators, how many times does x appear? Once. So x appears once. Looking at all 4 denominators, how many times does y appear? Once. Okay? You're going to multiply both the numerator and denominator by this LCM. So you're going to multiply by, and I'm going to write it, instead of writing it xy over xy, I'm going to write it xy over 1, because I need to multiply that numerator by that, divided by xy divided by 1. What is the value of this? What's xy over 1 divided by xy over 1? What's anything divided by itself? 1. So I'm really multiplying by 1. Okay? I'm not changing the value of the fraction. Okay, so you got to take this, look up here for a minute, times this. I want you to do it by sight. When you multiply this times this, what's going to divide out? The x's. What's left? Y. So you have a y left. Now multiply times this. When you do it by sight, multiply this out. The y is reduced and you have an x left. So minus x. The sign is still there. Multiply times this. What's left? xy, right? Nothing reduced, right? When you do this, what's left?
X squared y?
No, when you multiply this, the x is reduced, you have a y left, right? Plus y. Plus y. Is there anything? Let's see. We could factor out a y on the bottom, but that really doesn't do anything, does it? You could factor a y out and say x plus 1. Can't reduce anything. Either one of those would be correct for an answer. So a complex fraction You have to look at all four denominators when you find your LCD. Okay? And then go from there. Okay?